Certified Penetration Testing Professional, Module 3, Open Source Intelligence, otherwise known as OSINT. So now what we're going to do is look at the skills and techniques to gather intelligence about the target from various publicly available sources. OSINT, or Open Source Intelligence Gathering, is required for all types of penetration tests. And the way we like to say it is, it's non-intrusive, because we're not sending packets into our actual client or target, we're just reviewing information. OSINT through www, or the World Wide Web. So we know we can find domains on our different types of environments. So in the example here, as long as we've got it as part of our scope of work, we can go into, in this case, the Parrot toolkit, and we're using a tool called actual subroot master, right? That's the one you're seeing there. And then the other one on the right-hand side is one of the Nmap scripts that's available for brute forcing DNS. And you see what comes back here is all the subdomains of certifiedhacker.com. And once you start looking at certifiedhacker.com, now we can start getting the different attack surface. Because you might be a little bit surprised, but remember we're setting this up for you. If you look at the left-hand side, you see Cisco-phone. Are these Cisco phones, voice over IP phones, connected to the internet? Possibly. But that's why we wanted to cover the process so you understand how the process works and the domain keys and everything else. And now we have another tool called DNS Map that allow you to find the domains and subdomains, right? Different tools we can use on that. So the DNS Map, and then one of my other tools that we like to use is a famous tool called Fierce. So when you look over here on the right-hand side, you can see the DNS service for the actual domains and subdomains. For this, in this case, we're doing Fierce against certifiedhacker.com. We see it's hosted at Bluehost. So you can start picking up that information. And then what Fierce does, first it tries to do a zone transfer, TCP port 53, and that fails in most cases, as it says here, unsuccessful. But then it goes down and does what for you? It gives you the different subdomains. So it runs 2,000 different tests. But if we return back to the left-hand side, we see the blogs for certifiedhacker.com. We see the control panel, which is how we manage the website. So FTP, all these are concerns because this is information leakage. So as the tester, we want to show this information leakage is giving up attack surface and information that we can map against the target. And here's another tool for us that we like to use, GoBuster, SubLister, there's different ones. This is SubLister here. And SubLister goes through and then gives you all the subdomains. And then the example on the right is actual Netcraft. So the Netcraft tool can extract information as well. So all of these are tools and mechanisms we can use to get open source intelligence. Similar or parallel domain names. So now we can use this tool here, which is called URL Crazy. That's the one we can do. So we can start looking for similar domains. So if we know we've got, in this example here, Microsoft, we start looking for similar example names to Microsoft as an example. Just another mechanism tool to extract information, which is what we do with open source intelligence. Web search, we can do advanced operators. We have the Google advanced operators. We can create complex queries using that. We can filter by the file type, sort specific information regarding the target. We can get all this different stuff. Here's the web search, the different operators for the web search, right? The image search, those types of things. The groups, different things we can do there. The directories, the news, and the product search. All these are things we can do with the advanced operators. More advanced searches for you, advanced operators, link, cache, site, in title, those types of things. They're all pretty much self-explanatory. The nice thing is we can combine these into different things and obtain more specific results. There's the information, the site information, right, the in-URL information. All those are information that we have for our advanced searches. And we look here, we got information here from the different advanced operators of the web searches, right? Information there to extract more data and more information. And you want to experiment and practice with these and create them as part of your penetration testing toolkit. Have these specific types of queries that you're going to use to extract different types of information. And that's the goal with open source intelligence. Then we got the exploit database, maintains what's called the Google Hacking Database. Okay? Google Hacking Database has these different query strings. Those query strings are what we call Google Dorks. And now you can take that string and query for specific information, which is powerful stuff as well. So we got the exploit database, right? The different things in the exploit database, the Google Hacking Database, right? Information there. Have the advanced operators, different things we can do with the advanced operators. All things we can do when we're doing our open source intelligence queries. There's the Google Dork. There's the description for the Google Dork, the information, right? Those types of things. All those are things we can do for the organization. We can look for login pages. We can look for asterisk for voice over IP types of things, file types, remote logins. All these are different mechanisms we can use to grab information from the environment. So the first one on the left is voice over IP footprinting, and one on the right is VPN footprinting. So these are just examples of queries we can use to extract information. Here's Site Digger. Now, understand that a lot of these tools are going to require an API key, so you have to make sure you have an API key to use them. But this one's from McAfee and Foundstone, and you see it's using the Google Hacking Database, and it automates the Google hacking process. Diggity from Bishop Fox, the Diggity project will actually go in and allow you to extract information out of it that uses Google, Bing, and Shodan, all three. But again, you usually have to have an API key to use these tools. Then we can use Shodan. Shodan's a great tool. So the one on the left, we're looking for Cisco routers. And you see there, we've got a Cisco router return. And the one on the right, we're looking for webcams. So just by using these types of tools, we can search from the internet for all these different types of devices and strings and information to be publicly viewable from the internet. Geographic location of a company, right? Different things we can do with geographic location. So as you see here, you've got an nmap script that gives you the IP-geolocation. So in the case of Microsoft, we get the coordinates for the information. So we can find traffic conditions around the company. We can find a lot of information using these different types of location services. So we show you some example URLs there of how you can look that information up. And then the Google Maps and Google Earth. Now where would this come into play? This will come into play if you're set up to target. Remember, written authorization and permission. We're doing everything with written authorization and permission. If you're set up to target that, it comes into play when you have to do social engineering, because with these maps and all this information we can set up, we can look at the compound. We can look at, is there a gate? Is there a fence? Is there this? Is there that? So with social engineering and physical premises as part of your scope and part of your engagement, you can actually get the information and details to build an entire mock-up environment to practice for how you're going to penetrate or break into that actual organization site with physical access. Employees and email addresses is important because we can use that again. If social engineering is part of our scope of work. We can do it for phishing engagements, right? The employees' business and personal email accounts, right? We can look for information. We can send email, those types of information. All these are things we can do with email addresses. We can do email harvesting. We got on the left end there, we've got the harvester, right, from the Hacker's Choice. That's a tool that we can use as well. Phishing Frenzy, Metagoofle, more tools we can use to harvest emails from the organization. These are all the different types of things we can do. Key email addresses, right? So the Metagoofle, we can run through those different things, stuff like that. We can look at the certifiedhacker.com site, as you see here, but we're looking for docs and PDFs. We can extract all that information out, and we can find sensitive emails and lists of information, as we show here, where we obfuscated it because we didn't want to leak that information. But if we're testing the organization's site, we're testing it for what? Visibility, and that visibility leads to attack surface. So we want to make sure our clients understand that. Here we've got a site called Have I Been Pwned? Right? So you can put in your email address and see if you've actually been pwned, and it'll tell you if you have been. Of course, Pastebin is famous for listing people who've been compromised. Their credentials have been compromised and things like that. You can find it on Pastebin. Yeah. Most of us are probably on there because that's the reality. Remember the Yahoo breach? Over 1 billion accounts were breached. So more than likely your data in the Military Office of Personnel Management for the clearances, that was breached. So more than likely you got data that's on one of these sites, Have I Been Pwned or Pastebin. Listing the key personnel of the company, right? Dice.com, Monster, profiles, those types of things. You're looking for background checks of the key employees, the resumes, work experience, right? Projects, promotions, accomplishments. All those are things you have to consider. People search, we can use Pipple. People Finder, we can start looking for people. Why? Because we can use this, if social engineering is part of our scope of work, we can use this to extract information and use it to target people, right? Target people in the organization who were actually being hired to test, because an attacker is going to do that. So since the attacker is going to do that, we want to follow the same process as the pen tester. So social network websites, find information. Of course, we got LinkedIn information, we got Facebook, we got Twitter. We have all these different types of things, so we can find the information there as well. Web investigation tools, right? Web Investigator is an example here where you can investigate and look at the online records. Remember, most everything we have today is in online records, so we can do background searches, people searches, all those types of things. Types of network devices used in the organization, right? Different types of network devices they use, the firewalls, all those information. The ASA firewall, as we're showing here in the example, we're looking for job openings. So we got a job opening and we're looking for an ASA firewall experience. Probably means we have what? A Cisco ASA firewall. So now we go frequent those 2 to 3 vulnerability sites. We look for ASA vulnerabilities. There's been quite a few recently. And then we modify and start setting up our target database. So if we find a Cisco ASA firewall in our searches, we already have some ideas of vulnerabilities that potentially could be there unless they've patched those vulnerabilities. LinkedIn profiles, of course, used constantly by hackers, so we want to use the same thing. So you see here, this person here says who they're working for, and they're currently responsible for administration of Checkpoint Firewall 1. That's a little bit too much information leakage. Then they have knowledge in the Cisco ASA, and then they have knowledge of Cisco switches. So now you're starting to do what? You're extracting information from the environment, from public information, which open source intelligence is all about, and you're extracting that information that can be used when you're starting to build your target profiles and target databases. Then we look here, the network devices used in the organization, right? The newspapers, the classifieds, job search engines, those types of things. All these are different types of things we're going to use in the organization, right? Different types of systems administrators, right? Oracle database servers, Cisco routing devices, checkpoint firewalls. All these are different types of things that we're going to look at in the organization's infrastructure. Here's an example. So we're just showing an example of a senior administrator. They're looking for Active Directory experience. They're looking for different types of things. They've already told you they're an actual Microsoft Windows environment. Now, that's not a big deal. Most people are. But they also tell you they got VMware. They got EMC. They got Dell. They got all these different types of information that they're looking for experience in. So that's telling you this company has these products, these devices. So now, without any work other than public records, we've been able to extract all this information. which is good stuff for us. Then email headers. Always never underestimate the email headers. So we can use a tool like Email Tracker Pro, and we can do email header analysis. And now we can gain sensitive information about the recipient. And then we look at the multi-purpose internet mail extension. We can figure out and extract all that information by looking into the email header. So we got the IP address, of course, we got the authentication system, in this case SHA-256, and we got the mail servers. So we're able to extract all that information out of the email header. And then we just start documenting and creating our documentation trail for doing our report. Then we can start looking at network news protocol. You can look at news groups, those types of things, news group posting. You see here the example, somebody's talking about Red Hat Linux. Right? They're having a problem. In this case, they're coming from certifiedhacker.com. So if they're working for that company, they just told us they're using Red Hat Linux. So we want to discover if anybody's leaking information like this. We want to identify that. Come in here, we can do the footprinting, right? The trade association, the groups, the forums, the blogs. We can look for link popularity, look for alerts, competitive intelligence, products and services, and look at some products and look for what? Competitors. Look for different competitors and look for information about it there. Competitive intelligence with the Edgar database, BusinessWire, LexisNexis, and Hoover's, for example. So let's talk about OSINT, open source intelligence, through website analysis. So now we're looking at, can we extract contact names, phone numbers, email addresses from the website itself, right? So we start looking, we look for the copyright notices, the revision number, document numbers, versions, those types of things. If we find change logs, we find all these different types of things. Once we find those, we can start leveraging that information to get data. We can go to the archive.org website, use the Wayback Machine, go back and extract records from years ago. As you see here, the example here, we're pulling up Microsoft from many years ago, right? All those are different types of things we can do when we're doing our open source intelligence. We can look at the websites and look for the web updates. How often do they update their websites? We've got a tool for that called Website Watcher. That's a tool that we can do for that. We can look at the source. If it's a large web page, it could be a little bit difficult, but in this example here, we're showing the source of the web page. We can have back-end technology, external links, file system structure, scripts, all those types of things. What about OSINT, open source intelligence, through DNS interrogation? Well, we got the WHOIS database, right, by the registries, the registrars, the domain names, right, the queries, domain name details, contact details, domain name servers, IP addresses, right? All these are different things we can do when we're doing these types of things. And then we got registrars, which will cover the information of WHOIS is looking at. So we have here an example on the top on the right-hand side. We have the WHOIS command, and then the bottom one, we have the nmap script. So by doing that, we have additional information we can use. Here's an example of how to do it with a Perl script. So let's look at the code. What we call the shebang, user bin / Perl. Let's say I'm using Perl. I'm using strict, and I'm using the net function. And all I'm going to do is I'm going to go in and I'm going to do a split in a WHOIS and look for the information that's available through the WHOIS command. So just running by this little Perl script, I can run an entire net range for WHOIS. Finding the IP address blocks allocated to the organization. Of course, we have the registrars, as I said. Asia Pacific NIC is here, the ARINs, which is South and North America, and RIPE is Europe. These are examples here. You also have Latin American Caribbean, the LACNIC, and you have AFRINIC, which is for Africa. So we have 5 registrars that allow us to find the range, or the IP range, belonging to the target organization. As you see there in the red box, we're seeing where the actual network starts and where the network ends. We can actually find with the WHOIS database. We have an example here. We got the NS lookup, powerful tool we can do of NS lookup. We set our type to name servers, and you see these are all the name servers, in this case for Microsoft.com's domain. Different things we can do there. We can get the DNS records. Very important we understand the DNS records. DNS Enum, which is the tool on the top here. Sorry, DNS Recon on the top, DNS Enum below it. These are tools we can use, different things we can actually use on the machine, right? We point to a host IP address, MX record, name server, canonical name. All these are different types of things we can use when we're looking at different things. And by looking at these records, we can extract information. So as the example shows here, we see we've got an address record and we've got an IP address, right? HINFO records we should never see in the modern day, but we want to test for it. If you get an HINFO record, that is a record that includes the CPU type and the operating system. DNS interrogation with the dig command, right? Dig google.com, right? Different things you're going to do. So you run through dig and you look at the dig information, the different information for dig, and see google.com, the address record. You get the address record there for google.com and you have the additional information. If you go here, we can do a short output. That's the dig google.com plus short. That gives us a short information, and all we get is the IP address. So we can use both concepts. We can use the dig command without the short option, and with the short option, we just extract the IP. We can do specific records. We can look for the SOA. Remember, the SOA stands for the start of authority. That's the record that is the one that owns that domain. So that start of authority is the identifier of that domain. The MX is the mail record, and then the last one there on the right with the 4 A's is IPv6. That's for your IPv6 information. Here's a nice little Perl script for you to use dig. We go in here and we see we're going to set up a variable $dig. That's what that does. And it's going to go in and run the dig function command, as you see right there. And the dig function is going to print the entire dig query response using, as you see right there, the print command. So all we're doing is running the dig command using a Perl script. And it's going to run it over and over again and print out the actual, in this case, MX. The MX is the mail server record. And it's going to print out and show us that information when the output comes out. So this is a nice little Perl script that allows you to do dig as well. Obtain the name servers, we got the who is. We can use the cat resource record. You see the information there, right there. So we do the who is. We output it to RR. This is the example on the left-hand side. And all we have to do is cat or more RR, and you see the output that came from the who is command. So we can save that, save it to our organization. We can do the grep. We can look for specific names. And then the last example on the bottom right there, we can grep it and then grep the domain. So the last one is we got the name server and we got the domain as well. All this is information of how we can extract it. You can use tools or you can use commands. Again, the best way to do it is have a blended approach and know how to do it in different ways. In case one way doesn't work, you try the other way. Same with tools. So you got the DNS lookup tools from the internet, ultratools.com. So you see there, we're looking up Microsoft, and you get back the actual records of Microsoft. And then you get the live DNS lookup results, tools you can use. Reverse DNS lookup, remember the PTR record is the pointer record, and the pointer record actually the mapping from the IP address to the domain. So you see here we're running our tool DNS recon again, and we run our DNS recon -R, and then what do? We actually look for these two IP addresses. It comes back and tells you who owns those IP addresses, the domains. Tool I like to use for many years is UGetSignal. Can actually go and look at certifiedhacker.com. You can go extract information and get lists of possible domains hosted on the same subnet, different things like that, possibly hosted on the same server. As you see here, we found 4 domains hosted on the same web server, Certified Hacker, Human Care Health, and LST-STL. So what's that mean? It's hosted in a shared hosting environment. So when you test this, you have to be careful, because if you're scanning a server that's in a shared hosting environment, you're doing that, because if you take out this one server and you crash it, you just crashed everybody who's being hosted by that server. So make sure you have written authorization and permission to do that. Zone transfer, we said it doesn't work very often, but we can try it. We're showing you examples how to do it. The dig command, you see the AXFR. So when you get the AXFR is a transfer. And you see in this case on the left-hand side, the lower part says transfer failed, unfortunately. Right here, you see DNS lookup. We set the server, and we try to list the domain. So the bottom command is ls. So all you do is you set the server. Once you set the server, do an ls-d, and if it works, zone transfer was possible. Modern, you don't really run into it much, but you can run into it. And where I've ran into it the most is in a closed environment. Since it's closed, they think, well, should be doing anything in that environment, right? So you still want to make sure that the actual administrator has done their due diligence, because as a tester, if you get in there, you might find a zone transfer is allowed. So you always just block zone transfers. And the case where we actually found it was a railroad. So since the railroad was a closed and owned protected network, they never locked down DNS zone transfers. So within 10 minutes of the engagement and the contract, we were able to dump the zone, which that's all the records of all the actual machines within the railroad, and we pretty much had the entire environment just from that one. In this case, we ran Fierce. So in that case, running Fierce, we had the entire zone. There's no reason to try to brute force domains if we have the entire zone records, which is why zone transfers shouldn't be allowed today. But we still have to test it, because in some cases, like we did in that railroad, we found it. Here's an example of it. DNS recon, -T, AXFR, right? Remember, that's a zone transfer, -D, certified hacker, and again, it failed. So we're just showing you the process. In most cases, it won't work, but it might. And then you want to do what? You want to draw your network diagram. So it's all about trace routes. And what trace routes do is they manipulate the time to live field. So since they manipulate the time to live field, each hop it goes to, it decrements the time to live. So the first trace route that goes out has a time to live of 1. It gets to the actual next hop, and the next hop goes and looks at it, it's a time to live of 1. I can't decrement a 1 to a 0. If I decrement a 1 to a 0, that doesn't exist then. So what I do is I generate an error message, and the error message is ICMP type 11, which means time exceeded. It's a time exceeded message. So now the sender gets it, says, oh, 1 hop wasn't enough, increments it to 2. Then it goes to the first hop says, oh, it's a 2. I can decrement it to a 1. Goes to the next hop, can't decrement a 1 to a 0, generates another time exceeded message. So it does that as it goes through. Now, a couple quick caveats here. Windows uses ICMP by default. Unix and Linux use UDP by default. Now, you can use TCP options to send TCP or whatever package you want, but you want to understand that, because if you run trace route without putting in a parameter for what protocol type to use in Unix and Linux, it's going to use UDP. So just be aware of that. If you want to emulate the same default of Windows, then you use the -I option. Now that we've covered that, it's important to understand that trace route as it goes through is going to hit devices. So the device that stops it is probably a filtering device. If the filtering device is identified where it stops, we can change the protocol from ICMP if it's a Windows trace route. If it's a Unix and Linux trace route, we can do it with a TCP. And once we modify that protocol, we should go through that block. And now we've identified the filter, which in most cases is a router or a firewall. So here's an example for you. We do the trace route to Microsoft.com. Look what we got here. Hop 3, ***. So it didn't return anything. Hop 7 stars all the way through 11 till you get to 12. So a couple of things. It could be it's coming back and you're not sure what exactly is taking place, but when you actually start looking at it, and we see we got a script here from Nmap that'll do it as well, look at the bottom right, the Windows Tracer T. And the Windows Tracer T, hop number 9 is stars, but it gets to hop number 10. Well, guess what? Hop number 9 is probably the firewall in front of the device. So this is just a process you can use to help you draw your network map. So now that we know this, we start building our topology and map of the network. And once we start doing it, we know, because we use traceroute, where those filters are located. So now we can start architecting it based on traditional network design, which most people follow. Now we can manually architect it, or we can actually use tools that will draw a topology map for us. Smart Draw here and Glyphy are some of the tools we can use. Now, automating the OSINT process using tools, frameworks, and scripts. So all this process we talked about was pretty much manual. What about if we want to automate this process? We can do that. We had the capability. Maltego is like the super tool for this. Now, there's a free version of Maltego that's pretty good. And there's the commercial version of Maltego is like amazing, right? So what it does is it takes and generates what we call transforms. So relationships and real world links among people, groups, and people in social networking. And when you start looking at it, it takes your email address, as you see here in the example. First we got this guy, Renee Matthews, and then we go into the right-hand side and we start mapping this person's email address into all the different social network accounts they have. So it's a good tool to experiment with, and the free one works for most of us because it doesn't go that deep. But put in your email address in this tool and see how many accounts you've used that email address. If you've had LinkedIn, Facebook, if you use the same email address, it will map all that information and create information and build a profile for you. And when they build that profile for you, then they can actually target you, and that's the tool. FOCA from 11 Paths, it's a great tool. It allows you to collect information. As you see, not only does it collect information, look at that actual image. You see here, we got the network, we got the domains, we got the roles, we got vulnerabilities, we got the metadata. So we have all this information just by running the FOCA tool. So the FOCA tool is extremely helpful in doing this type of stuff. F-Society is another one. It's a tool which has scripts for our pen testing. As you see, we got information gathering, password attacks, wireless attacks, exploitation, sniffing and spoofing, web hacking, private web hacking, post-exploitation, install and update, of course, to update the tool, all kinds of stuff. So if we go into one of these, in this case, we're going into information gathering, we see we got Nmap available, we got SE Toolkit for Social Engineering Toolkit from Trusted Sec and Dave Kennedy, host IP, WP Scan, CMS Map, cross-site scripting, dorks, crypts, all these different things we have available in the F-Society tool. PENT Menu is a bash script that allows us to do information reconnaissance. As you see, we can do recon, we can do denial of service, extraction, all these different tools, there are different components we can do with this, and it's inspired by a thing called PENTBox. It's just makes our job a little easier, runs all these different types of things for us. And then like everything, most important for our follow-on and our deliverable, we got to document our results. So we have to get the domains, the subdomains, locations, employees, anything we get, we're going to document it and include it in our report. So in this module, we covered a lot of information on open source intelligence. Well, when you have open source intelligence, it's extremely important that you follow a step-by-step guidance plan to extract all this information from targets. So we covered the information we could do. We could grab the web information. We could use searches on the web, Google hacking databases. We could do all these different components of open source intelligence to gather information about the domains, the physical location, the employees, telephone numbers, all these things we looked at we can use as part of our open source intelligence. And finally, we can use the traceroute or tracer T in the Windows world to identify where our filters are located at and draw our network diagrams. And this concludes the module.